Here's an example of using the product rule to differentiate when you have two things that are multiplied together. So here we have x plus 1 and a natural logarithm. Even though there's no multiplication sign, we understand that we have two terms. We have something, x plus 1, and we have a log, and they're not added together, they're multiplied, even though there's no visible multiplication sign. So we have two terms. So the first thing you want to do is to differentiate each of those terms. So if u equals x plus 1, then the derivative of u is simply 1. And then if v is the log, natural logarithm, ln of x squared minus 1, then the derivative, when you differentiate log or ln, the derivative is simply 1 divided by the argument x squared minus 1. So that's how you differentiate ln. You just pretend that's x and then put 1 over x. So whatever you have here, you put in the denominator. But because this isn't x, because it's a function of x, you need to then multiply by the derivative of that function of x. So here we have a function of x. So you need to multiply by the derivative. And that multiplication is courtesy of something we call the chain rule. So you want to multiply by the derivative of x squared minus 1, which is 2x. So we can put here multiplied by 2x. And when you have a multiplication by 1, you might as well not mention that and just keep the 2x. So that's the derivative of the natural logarithm. So ln x squared minus 1 gives you 1 over x squared minus 1 multiplied by this derivative, or the derivative of x squared minus 1, which is 2x. So now that we have all these, we can put it into the product rule and say dy by dx equals u dash v, so that's 1 multiplied by ln, plus uv dash, so that's x plus 1 multiplied by 2x over x squared minus 1. Now, notice that when I multiplied this by this, I needed to put brackets around this, because if I hadn't put the brackets, if there were no brackets, it wouldn't be clear that the whole term is being multiplied. You might think that it boils down to x plus 1, and only the 1 is multiplied. So it's really important that you put those brackets. And that would normally be your final answer. So you can remove the 1. But if you look carefully, it looks like we can simplify that, because this denominator here, it's something that we call the difference of two squares. Okay? Because you've got two squares, x squared and 1 squared, so we can use the difference of two squares to factorize that. And the reason is because we will end up not having that term. So it's just a method of simplifying. So generally when they want you to differentiate, they want you to simplify it. So you can express x squared minus 1 as x plus 1 times x minus 1. So in general, if you have x squared minus a squared, you can factorize it as x plus a times x minus a. And if you remember that 1 is a square, it's the same as saying 1 squared. It's just an example of difference of two squares. So now I can rewrite this by putting that in there. So my expression for dy by dx, I can get rid of the 1. It's simply ln x squared minus 1 plus x plus 1 times 2x divided by... So this I can put up there in the numerator, and in the denominator I'll have x plus 1 times x minus 1. And now, if you notice, we've got x plus 1 in the numerator and in the denominator, and those two simplify to 1, so we can cancel those. So that's my final answer is ln x squared minus 1 plus 2x over x minus 1. And that now is your final answer. So even though this answer here is correct, it's not the simplest form, so it wouldn't be accepted as your final answer. You would still be expected to simplify it. All right, so you need to know how to deal with the difference of two squares. You need to be able to recognize it when you see it. So that's another example of using the product rule.